Hello everyone. Today we're going to talk about one of the easy problems in Leetcode, and this is problem number 20, and this is one of the problems in blind 75 list. So let's go to the problem statement. So we have to find, so we are given a string S, and this string consists of these 6 characters, so different kind of parentheses, opening and closing parentheses. So we have to determine if the input string is valid. We are given a string that is made of different kind of parentheses, 6 type of them, these parentheses characters, and we have to determine if the input string is valid. So here are the conditions for a string to be valid. First of all, the open brackets must be closed by the same type of bracket. So that means if this is this type of bracket, this only can be closed by this type of bracket. This can be closed only by the same type of bracket, and this can be closed with only the same type of bracket. So that's the first condition. Okay. The next condition is open brackets must be closed in the correct order. That means if you have something like this, now you see that this is not closed in the correct order. That means when we actually get this one, this is not, so this one is not closed by the correct one. So this is a wrong, there is no match between these two, right? So this is not closed properly. Okay. So this must be something like this. Say this. This is right? This is closed properly. And then if I have another of this has to be closed with the similar kind of bracket. And finally this one. So you see this one matches, this one matches, this is matches. So this is a valid string. And every closed bracket has a corresponding open bracket of the same type. That means if I have something like this, right, at some point, there must be corresponding this at somewhere. Okay, so that is important. Suppose if you have something like this, it's not working because when you have this, you still don't have something like this. So there is not it's missing, right? So this is also not a valid string. Okay. So in the examples here, suppose this one, right? This one is closed by the same type of bracket. So this is a valid one. Here also, each of the closing ones have are closed by its corresponding bracket. So this is also a valid one. But the last one, here you see that this closing one doesn't have the similar kind of opening one. So this is not a valid one. This is false. Okay, so I would suggest everyone to pause this video and think for some time that how you can determine if your given string is valid or not. Okay, so I hope you have probably thought about something. Probably you have already found the solution, or if you haven't found the solution, probably you have something like probably thought something, but that might be wrong. Let me talk about some of the wrong thoughts that we may have. The first one is probably a very naive thought might be, okay, let's count how many times we have this, how many times we have this, how many times we have this, and how many times we have this. So let's count each of these characters. Say this one is 5 times, this is 5 times, this is 3 times, this is 3 times, and then this is 4 times, this is 4 times. Then probably we can say, okay, probably this is right. This string is correct, but that is not right because see this one, for example, this one, you see in this case, we have all of them for one, right? Sorry. Each of them are each count is 1. But the thing is, this is not valid because you see, when we actually get this one, right? This one, this is not closed by the right type. So it's not closed by its own type, right? So this is wrong. Okay, so next, so this count is not right. Also, suppose if we have something like this, in this case, we have both of them 1, but the thing is, the first character is this one. So already when we actually get a closing parenthesis, we have to have something, an opening one that is closing, right? So when we actually reach here, still we don't have an opening one, so that's wrong, right? So that violates the conditions. That means just solely counting these numbers is not going to work. Okay, so that means we have to focus on, like, whenever we have a closing parenthesis, right? Whenever we have a closing parenthesis, if we have this, we have to find that, okay, is the last open one is this, right? That's important. If we get this, we have to find if the last open one is this, right? Okay. If we find something like this, we have to find if the last open one is like this. Okay. So that means if we store the character somewhere, like if we store the character somewhere, and whenever we get a closing parenthesis, like each of these, we have to see if the immediate open one does match, right? That means the last open one. So at this point, I want you to think, like, sorry, what kind of data structure is helpful to find, to check the last opening one or something, right? What kind of data structure is helpful? You can pause the video, think for a moment from the data structures that you already know, and then you can come back. Okay, so probably you have thought, like, what kind of data structure? Probably, yes, you have thought right, whoever have thought about stacks. That means we can actually put, whenever we have something opening brackets, suppose something like this, we keep putting them in the stack. And whenever we have a closing bracket, say we have this, suppose we have found this, right? Then we check, okay, if the last one matches. In that case, we say, okay, this one matches, so we are done. Then next time we get this one, we say, okay, the last one that is on the top of the stack, does that match? And if it matches, then we remove it, right? Now, say at this point, we get another opening one. So we put it here, and then, so whenever we get a closing bracket, like suppose this or this or this, we just check the last open bracket if that matches or not. Okay, so we keep on doing this. And the thing is, suppose, let me show you one example. Suppose this is one example. Okay, so let's say we got the open one, so we put it in the stack, and then we get another open one, we put it in the stack. We get a closed one. So whenever we get a closing one, we have to go to the top of the stack and see if it matches. So we see that the top is the stack matches. That means, okay, this one has a matching. Then we get an open one again, open one again. So we put it in the stack. Then we get another open one, we put it in the stack. Then we get a closed one, and now we check the top of the stack and see if they match. And you see that the top of the stack actually matches. Then the next one, this is open one, so we put it in the stack. We get a closing one, and now we check the top of the stack. This one matches. All right, we are done. Next, we get this again another closing one, and we check the top of the stack, and this one also matches. But still, this is not a valid parenthesis, valid string. The reason is the stack is not still empty. That means we still have something in the stack, right? Okay, so after everything is done, we have to check if the stack is empty or not. Okay. Or we can do it in another way. We can just check the size of the string. If the size of the string is like odd, string size is odd, we can immediately say that, oh, this string is not, actually with your odd size string, you cannot just match the parentheses, right? Okay. So let's go and try to code this. Yeah, let's try to code this in Leetcode. So this is the problem and this is our solution. So first what you can do is, if string length, we will check if this is even or odd. If it's not equals to 0, okay, in that case we will return false, because the string length has to be even for the parenthesis to match, right? If that is not the case, then we will use a stack of type character. So this is going to be used to store the open parenthesis, and then we will go iterate through the whole string to see whenever we get a closing parenthesis, then we will check against the stack, or if we have an opening parenthesis, we'll put it in the stack, right? Okay, so say to go to each character, we will just go through the string through the character indices. So, and we'll do it for the whole string. That means the size of the string. Okay, so every time we will just pick a character that is character.index, and then we'll check if this character is equals to, if it's closing, then we'll check the stack, right? Or, okay, so if this is this type of thing, so first we have to check if the stack is empty. That means there is nothing to match, right? If the stack is empty, that means there is nothing to match against this closing parenthesis, then we already say, okay, failed, the validation failed. Or if the top of the stack, that means the stack is not empty. If the stack is already empty, that means there is no opening parenthesis to match this. But if the stack is not empty, but is still the top one doesn't match the correct opening parenthesis, we can say in both of these cases, the string validation fails, so we return false, and then we are done. So we do the same thing for the other two types. Okay. So this is of type this, then we have to check the same thing, but we have to get the matching opening parenthesis. If this is this, then we have to get the matching open parenthesis. Okay, so this covers the scenario when the character at that ith index is a closing one. Otherwise, it means that the character is an open one, right? Opening one. In that case, we don't do anything. We just push it into the stack. Okay. Okay. So otherwise, you put it into the stack. So we keep on doing it until yeah. So we keep on doing it until throughout the length of the stack. Okay. Now, suppose the case might be, suppose like something like this. Say the input string is something like this. It only had these open things, right? Okay. So suppose something like this. That means the string length was even, but there were like more open ones than closed ones. So these two matched and they matched each other, but still the stack is not empty. So we have to make sure that all pairs are matched. If all pairs are not matched, that means still there is something there's something in the stack. So I have to make sure that by the time I have gone through everything, I have gone through everything, the stack is already empty, right? So everything, okay, the stack. Okay, so let's try to run. Okay, so I've written everything as st. So I'm fixing the name. Okay, so the test case is passed. Now let's try to submit it. Okay, now you see that the submission is done and it actually beats 82%. So the runtime was very fast. And the final thing, like what is the complexity? Now you see the complexity of the algorithm that we actually worked on is each character. We actually went through the characters, each character, we read each character once, right here. And they were like either pushed into the stack or popped into the stack, or so basically for each of the characters we just did a constant number of operations. Either we did a pop or we did a push, right? So if the length of the string is n, then we can say that the time complexity is order of n. Now the space complexity is also order of n, because in the worst case, my stack will have like n elements in the stack, because say for an input like this, right? For an input like this, say. So in this case, all 4 elements goes into the stack. Obviously, this will fail, but this is the worst case. That means all elements are actually pushed into the stack without getting popped. So the worst case space complexity is also order of n. In that case, the stack size would be n. Okay, so that's it. Thanks for watching.